Okay, so we did volume of a cylinder. So if you look at example 1 here, the cylinder and the cone have the same radius and the same height. And if you notice, this one has a volume of 120 inches cubed, and this one is 40. And they have the same height and the same radius. Example 2, same thing. They're telling us the radius is the same and the height is the same. And this one has 90 inches cubed and this one is 30 inches cubed. So what do you notice about the volume of the cone compared to the volume of the cylinder when they have the same radius and the same height? So pause it and think about it for a little bit. And what you should notice is that the cone is 1/3 the volume, 1/3 the size. I'm just going to put size, but you can say volume, is 1/3 the volume when they have the same height and radius. Obviously, that would be different if they're not the same, but whenever they're the same. So that's how we get the volume formula for cones. So the volume of a cone will always be 1/3 the volume of a cylinder when they have the same height and radius. So the formula for volume is almost the same as a cylinder, except we have to add in that 1/3, so it cuts it in 3, or divides it by 3, I should say. And then we do the base, the area of the base, which is still going to be a circle, times the height. And then they said you can also do it like this, which I like. Base, area of the base, times the height, divided by 3. Because timesing by 1/3 is the same as dividing by 3. So since the base of a cone is a circle, the area of the base is found by using pi r squared. So we're going to use 3.14 for pi. So we're going to look at this. We're going to see that it's a cone. We know the formula for a cone is, I'm going to write pi r squared times the height, and then I'm going to divide it by 3 because that's the one I like to use. So pi r squared represents finding the area of the base. So we have pi is 3.14. And then the radius on this one is 5. 5 squared is 25. So that's 25. Times the height is 12. So even though it's laying sideways, the height is 12. And then we're going to divide all that by 3. And when you do all that, you should get 314 inches cubed. Okay, now we have this cone. So we're going to do area of the base, pi r squared, times the height, and then divide it by 3. So pi, the radius, the diameter is 22, so we know the radius is half of that. So 11 squared, and then the height is 10, and then we're going to divide by 3. So make sure you only square 11, 11 times 11, and then times everything and divide by 3. And you should get 1,266. And then if you put some decimal points from your calculator, it's 0.46 repeating. I mean, you can round it or you can use the whole number. It doesn't tell you what to do, so centimeters cubed. Again, pause it and rewind if you need to. Okay, the volume of several cylinders is shown below. So remember, that was our first lesson with cylinders, just the area of the base times the height. And it says, note they're not drawn to scale because they just have the areas written on here. So it says, use the dimensions in the table below. So they give you the radius and the height, the diameter, the radius, to find the volume of each cone. So first we're going to find the volume of the cone. Then under this cylinder, we're going to record the letter that would be the same height and radius as the cone. So let's find the volume of the cone for the first one. So we're going to do pi r squared times the height divided by 3 because we're finding the cone. So we're going to do 3.14. The radius is 8, so we're going to times it by 64 because 8 squared. I'm putting dots for times. The height is 2, and then divide by 3. So that volume should be 133 point, we could just round it. I'm just going to do 0.97. And then it's units cubed. So if we know that the cone is a third of a cylinder, so it's basically going to take 3 cones to get into the cylinder, we're just estimating we could times this by 3. And so 133 times 3, I'm going to do it up here. I'm just going to do that. That's going to give us 399. So the one that would be closest to that, because I rounded, I didn't use the decimals. That cylinder is going to have the same radius and height. Okay, for this one, we're going to do pi times the radius is going to be 3, and then 3 squared is 9, times 4 divided by 3. And when we do all that we get 37.68. So I'm just going to round that to 38 to be able to do it easy. And I'm going to triple that, because if that's the volume of a cone, then the cylinder with the same height and radius is going to be 3 times as big. So that would be 114, and the closest is going to be E. Okay, next one, 3.14, and the radius is 2.5. And so we're going to do 2.5 squared, not times by 2. And then times the height divided by 3. When you do all that, you get 13. I'm going to round it to 0.1. There's some decimals, but I'm rounding it. And then when we triple that, we get 39. And so that would be letter B. Okay, next one. Some story problems here. The cone below has a diameter of 12 and a slant height of 10. Find the volume. So the the height is 10. The diameter, which is all the way across, is 12. So we want to find the volume of the cone. So the cone is a third of the cylinder. So we know we're going to divide by 3. So we're going to do pi. The radius is going to be 6 because it's half of that. 6 squared is 36. And then times 10 divided by 3. So you should get 301.44. And then it would be units cubed. We don't cube that number. If there's no label, you can write the word units cubed. Okay. Number 5. Isabella constructed a cylindrical vase that has a volume of 63. Jason constructed a cone that had the same height and the same radius as her cylinder. What is the volume of his cone? So we might have to do a few things here. So if she constructed a vase that was a cylinder, we have to find out her height and radius. So if we do volume equals, let's see here, pi r squared times the height I have to pause this for a second and think about this one. Okay, so I don't know, I had a brain fart. So the volume is 63 equals, and we know pi. Oh, wait, yeah, this is why I'm confused, because we also have to have the height in there. And we don't know the radius, and we don't know the height. So I am still confused on this. Oh my gosh, I had a total brain fart. I'm way overthinking this. So the keywords are if they have the same height and the same radius, then we know that the cone is just 1/3 of this. So all of this was dumb. We just do 63 divided by 3. And then we know that the cone is 21 centimeters cubed. See, I even get brain farts once in a while. Okay, a cone has a volume of 300 units cubed, and the cylinder has a volume of 100. Is it possible that they have the same height and the same radius, and why or why not? So pause it and think about it for a little bit. So it is saying that the cone is bigger than the cylinder. So at first you might think, oh yeah, because this is 1/3 of it, or this is timesing it by 3. But they have it, the cylinder should be bigger than the cone if they have the same height and radius. So they are trying to trick you there, but no, it would not work. A cone has a volume of 492 cubic inches. What is the radius? So we're going to use the formula for the cone. So we have volume equals area of the base, which is pi r squared, times the height divided by 3. So we know volume is 942. We know pi is 3.14. We don't know the radius yet. We know the height is 9. And we're still dividing by 3. So how do we solve for r? Well, you can do a couple things. If we're just solving for the equation, I would simplify this side, and I would do 3.14 times 9, which I'm getting my calculator out here. So 3.14 times 9 is 2826. And then, so then you have 28.26 r squared divided by 3 equals 942. So how do you get rid of that dividing by 3? You times by it on each side. So 942 times 3. So that gives us 2826 equals, and then 28.26 r squared. And then we're going to divide each side by that number, 28.26. And that gives us 100 equals r squared. And then we take the square root. So what is the radius of the cone? It is 10. That is why writing the formula helps you when you are solving for something besides just the volume. Okay, so you definitely need to practice on the homework.